I got one of those, but I
Yeah.
don't know where it is.
We won't even do this one. How would you do it?
Well,
Oh, that car is.
Would you take the momentum?
Right, so you know momentum is a conserved quantity, right?
Wait,
So the total momentum of the system has to be the same before and after. What's the system include?
The system is just two training, the freight cars.
Both of the cars together, right? So if you added up the momentum of car 1 and car 2, and keeping in mind they're vector quantities, so we'd assume they're moving in the positive direction, right? The one that's moving, the other one's at rest, then whatever that combined momentum is, mass times velocity of each one added together, that's what it has to be after the collision also. But if they stick together, then you know that the combined mass, they become one object with a larger combined mass. Mass times velocity has to be conserved, right? So that one's no big
It's gonna be
deal.
a little less than half.
A little less than half, right? On that one, right? Because the stationary car has slightly more than half the mass.
I think the car would survive.
You have it as one-dimensional.
No,
How
they're
did this
not,
change
but,
with
like,
like?
the
car's way
Isn't it always one-dimensional? Because it would always kind of stay.
like-
like-
No.
That
We'll
makes
do,
sense.
the next
I
time
was
it's two-dimensional
confused as to
problems.
why.
Is that
Hey,
right?
hey,
More than a train.
Okay, what about that one?
So is that one are they moving towards each other?
So, yeah,
Yes.
opposite direction.
Okay, so you would have to take the momentum of both of them and then subtract.
Right, now you have to, so one point I want to make with this, so you can define what's positive and what's negative, and as long as you're consistent, you can answer the question without ever using positive or negative, right?
Mhm.
I mean, you want to pick the most convenient way to do it, but, so we'll, just a picture of this. So if we represent this with a picture, we've got object 1. Let's say it's moving to the right, the positive direction. Right, so you got object 1, mass of 281,000 kilograms, velocity in the positive direction, 2.59 meters per second, colliding with object 2, mass 398,000 kilograms, moving toward the first car. So it's got to be moving back in the negative direction. Speed of 0.550 standard units, meters per second. Okay? So what can we do?
Find the momentum of each individual.
Okay, so the momentum, somebody with your calculator, tell me what's this going to be? So P1 is what? What's they give us? Somebody's got a calculator. 2.59 times 281,000.
So it's just mass times velocity.
Mass times velocity is momentum.
Go along.
what is it?
7.59.
Yeah,
Say it again,
got it.
Richard.
727790.
727790, that sounds about right. And that would be standard units, kilogram meters per second, right? It's positive. What about this one?
21890.
21890, okay, but
I got another 0 too. It's 218,900.
That sounds about right.
Yeah.
yeah, that's good, okay.
Jesus.
But what's wrong with that one? Remember, it's a
Negative.
vector quantity, it's gotta be negative, right? Because it's traveling in the negative direction.
Negative.
Okay, so then that means that if we add those up, what do we get?
About 500.
Oh, hold on. I do. I
I
didn't realize that.
We can just see.
509,000.
508, 8,
Yeah, actually, it's
508,000.
yeah.
Are you kidding?
200 and
890.
200,
I got it.
I'm doing it in my head. I could do it.
890,
No, yeah.
890.
508, 890.
Yeah.
Oh yeah,
Nice.
heartbreak.
94,000. I guess 90 million. 46,000 then.
So we'll pick it up tomorrow, but that's the momentum of the system then, right?
And then you just add the weight, the masses together and then divide.
Divide the total momentum by the masses to find the velocity. Yep, there you go.
This is like easiest stuff you've done.